Right, let's start. So, introduction to computing. So, introduction to operating systems. So far we have discussed about the input-output devices and why we should learn computing and what is the use. So, last week we have discussed about those things. So, today we are going to dive deep into the how a computer works with the operating system. So, let's see. So, what is an operating system? So, imagine about a vehicle. So, you have a vehicle and you have all the structure, but you don't have an engine. If you don't have an engine, no matter how perfect is the other parts, but you can't run the vehicle and you can't drive the vehicle. You can't get a use of that. But if you imagine you are going to paint your vehicle, you're going to paint it, and you're going to fix new uh, seats for your vehicle. But no point if the vehicle is uh, not running and you don't have an engine. Engine is the most critical part in a vehicle. So, other example. So, if you take a computer, you have this casings and the other displays and stuff. But the thing is, uh, you can't run any software there because you don't have the operating system. You don't have Mac OS or XP or Windows or any other operating systems there, then you can't play any game or you can't run any other software. So there, the operating system is the most critical part of a computer. So without the operating system, the hardware parts can't be operated. So it's like a vehicle without an engine. So the operating system is like a engine. So if you don't have the operating system, it's like a vehicle without the engine, right? So we'll discuss with some other examples also. So let me erase these things. And normally, a modern computer consists of one or more processors, and we have the main memory. So you know what is main memory is? Main memory is the RAM. So I have updated the Simon marks, or sorry, the unit test mark also. So Venerable Dhammadasi can send it when he's free. So other uh, Venerable has sent it, and I have already given the feedback. So thank you for the answers. And also we have the disks and printers, and as we discussed last week, we have various input and output devices. And also, the writing programs that keep track of all these components and use them correctly, let alone optimally, is a difficult job. It means, so controlling processors, controlling main memory, controlling disks, controlling printers, and each and every input device alone is not possible. So imagine you have given the task of controlling the keyboard, output devices, all the displays and other stuff. It's very tiring. You can't do it. So even you can't control a group of people uh, around 12:30, right? 12, 12, 20, maybe 100. You can't easily control them. So imagine about the computer. So let me show you something. So when we are running this software, so I'm reading a PDF and I'm recording the lecture here using this software, and in the meantime in the background, so if you go and click on the start menu and press the task manager, in the background you can see thousands and thousands of processes are running. Here if you go to the services, here you can see how many processes are running in the background. So here you can get a good idea using the process ID. So here the PID means process ID, it's 15,720. So that much processes are running in the background without your intervention, right? So then what is an operating system? For this reason, because the here in computers we have three parts. We have input process and output, and also we have the liveware. We have the liveware, and we have the software, and also we have the hardware. We have the hardware. So the problem with these three parts is these three parts don't have a common way of communicating. Liveware means us, the humans, and hardware means you can take the computer display, the keyboard, mic, likewise those stuff. And the problem is when you give an instruction directly to the hardware, it can't understand it, because the hardware will understand only ones and zeros, because those are physical electronic devices. So then you can get the help of the software. So what software does is, software will convert. So imagine you need to print hello on a piece of paper, but you can't directly say to the printer, printer please print hello. So you should use the software. So you can use MS Word, and using MS Word you can press the print button, and that will give the printer the option to print hello on the paper. So that's how it works. So it's obvious. Then that's how it works. So the software is the one who's going to bridge the gap between the liveware and the hardware. So without software you can't directly instruct or do any job using the hardware. So let's see. For this reason, computers are equipped with a layer of software called operating system. So this is a special part of software. An operating system is a program that acts like an interface between the user and the computer hardware. So here we have discussed about two types of software. We will discuss application software and system software, two types, right? And so here it's saying about the operating system, right? So then further details. What is an operating system? Yes, this is the graphical representation. You have the user and you have the hardware, but the thing is you can't directly communicate with the hardware. So then first layer software, we have the application software, and then we have the operating system. It's also a software. So here another example. So we have the hardware here and we have software. So here this is the place the user is there. So user is using the software to give instructions for the hardware. And here some application software here, web browsers, email reader, music player. So it has the user interface. So here if I open this software, here this is a user interface. So here we have stop button, start button, likewise, and then we called it as the user mode. So no need to remember these things, just remember in every software you have user interfaces. And then we have this operating system. So it is the kernel mode. It's a technical term, no need to remember those things. And here we have some examples for operating systems. So we have the Windows system, the system I use, Linux and Mac OS. And also we can list the Android systems, and we have the new Huawei Harmony OS, Huawei, right? So these are some older versions, XP, Vista, Windows 7, Windows 8 and Mac, right? So these are some examples. So we'll discuss about them later. Any question? Yes. Yes, it's also operating systems, the iOS, mobile operating systems, and we have BlackBerry OS, all these things are mobile operating systems, and generally we can call them as the operating systems. And here we have some other options also, Ubuntu, and here, these are Linux distributions, Fedora, CentOS, Red Hat, Debian, and these are some Linux distributions. So we'll talk about it later. Right. So now we'll browse. Yes, yes, you can get Windows 11. So this during the preparation of this slide, Windows 11 was not there, but Windows 11 also an example of operating system, right? So anyway, so let's browse the internet and see how we can understand the operating system, right? So that is the best way to learn things. So let me go to the browser and type uh, what is a computer operating system is. If possible, let me show you a video clip also, right? So yeah, an operating system. Any problem with Damadasi? Right. Uh, Thank you for letting me know. All right. Okay. Anyway, just forgot the rest of thing. I'll start over. Right. Right. So let's see what is an operating system is. I was just telling about these things. What is an operating system is, and uh, just 4 slides. Right. So let's start from beginning. Doesn't matter. Right. So now hope you can see my screen. Now can you see? Okay. Right. Thank you for letting me know. Right. So now I'm going to search in the browser what is an computer operating system is. So according to the search results, it says an operating system or OS is the foundational software that manages the computer's hardware and software resources. So it will provide a platform for applications to run and allow users to interact with the system. So let's see it in simple terms. Let me go back to the slide here and let me erase this one. So no need to think about these things. This is just basic thing. What is an operating system? A modern computer components, right? So let me erase this thing. Right. So according to the input, output, and processing knowledge, the things we have learned last week and during the other sessions, basically computer has 3 parts: the liveware, the operators, and we have the hardware and the software. So the problem with the operators and the hardware is the operators can't give direct instructions to the hardware. So imagine you need to print a document called hello, but the thing is you can't directly go to the printer and ask printer please let me print a document called hello. So you should use a software. So you can use MS Word. So using the MS Word software, you can type here and give the instructions to the printer. So then you can easily print the hard copy of the your document. So imagine you need to edit a video. So you are the user and you need to edit a video and you have your raw footages on your mobile phone. But the thing is, you have the idea how to edit it, but you can't edit it manually and save it on the hard disk or a USB pen. What you should do is, you should use software like a video editor. So you can use Premiere Pro, CapCut, some software, and through this software you can edit it and save it to the USB drive. Right. So I hope you got my point. Is it clear? Right. So our other Venerable, are you clear about that? What is the concept of a software? Okay. So let's continue. I think no problem is there. All right. So if you have any problem, please unmute yourself and please ask. Right. So that is why we need the software. We need to gap the bridge between the liveware and the hardware. So the thing which bridge the gap between the liveware and hardware is the software, right? So let's see some interactive examples. So let me go to the browser and let's go and see a video. So let's see whether we can see a video. Right. So introduction to operating systems, OS functions and features. Right. Right. So let's go and play this one. So I think you can hear the uh, system audio. Let me check. So can you hear the YouTube audio also? No. Right. I think I should change the settings. So let me check how to share share audio in the bottom left corner of the pop-up. Right. Let me unshare and share it. I think there, that way I can share it. Stop presenting. And okay, now I think okay. Now I think if I play, you can hear it, right? So can you hear it now? Right. Right. So that's it. Right. So it's a little clip about operating system. So let's research more. Right. So let me again share my screen. Entire screen. Right. Okay. Now we can see my entire screen. So right. So I have learned something new, right? So how to share the YouTube audio during a Google Meet. Right. So anyway, so let's go and see some other examples. Can we see a picture there? Alright, so let's select this website and see what is their definition is. Right, so here, so it says the operating system is a collection of software components of a computer system which is reliable for the management, coordination and the sharing of the resources of the computer. It is employed to manage the computer hardware and also provide interface for the users. It also gives isolation, security and protection among numbers of user programs. The operating system acts as a mediator between the user and hardware of the computer. So we have discussed about this one, right? So we have the hardware and we can't directly interact with the hardware. So we need the operating system, right? So any other things, right? Right now, so this graphic we have seen this, right? So back to the node, right? So I hope you have got the idea. Now let's proceed. So what is an operating system? So again, so this is a graphical representation. So imagine you are going to download an image from the browser, from the web browser and save it. So you can't directly download the image and manually save it on the hardware or the storage device. So what you can do is you should work with the operating system. So first you will browse an image using the web browser, then you will the operating system will work with the web browser and it will save the image onto your local hard disk, right? That's how it works. Yeah, user will work with the application software. So in this case it's the web browser, and then it's going to the application software is going to work with the operating system, then finally it's going to deal with the hardware. Yeah, so operating system will act like a bridge here. Right, so let's move to the other one and then some examples. So some examples, so you can see examples on the web also, operating system examples. So here you have some examples here, the Microsoft Windows 1, Chrome OS, Linux, iOS, Unix, Fedora, Android, Ubuntu, BlackBerry OS, Mac OS, likewise. So those are some examples for operating systems. We have both mobile and other desktop versions also. Right. So let's proceed further. Operating system as an extended machine. So this is a little bit theoretical one. So let's see what is it saying about the architecture, instruction set, memory organization, input output and bus structure. No need to remember these things. The architecture of most computers at the machine language level is primitive and awkward to program. It's true. So if you take a computer hard disk, so let's see a computer hard disk, so you can't directly program it because there are electronic parts. Yeah, you have electronic parts and you don't have the knowledge to work with these things. Even you have the necessary knowledge, you can't easily work with these things. So imagine, so here the terminology behind this disk is, so this here saved file is a little scratch on this disk. So can you manually read this thing? No, not possible, no way. But with the use of the operating system, uh, it will help us to read files. So imagine your lecture slide. So I have used this, let me open my file explorer. So my files, all the files here, I have some folders and here I have some files. So these are stored on the hard disk like this. So here saved files is like a little scratch on the hard disk. So that is how the files are saved. So I don't have any way to read these files manually. So what I can do is I can get the help from the operating system. So since I'm using the Windows 10 operating system, it's going to list all the files for me, so it's doing a great help for me, right? So then, so that is the idea behind this one. So users does not want to involve with the programming hardware. So here another example, so I'm using the web camera, so think I should manually wire it and hold it somewhere and do the lecture. So it's impossible, but the operating system does it within one click. Using one click I can turn off the camera and turn on and turn off. So it's helping me. Instead, what users want is a simple high level abstraction to deal with. So what is the high level abstraction means? Here, if I need to turn on the camera, I can go there here and press the button here. I don't need to manually switch on and switch off the camera. If I need to turn off the microphone, I can press this one to mute the microphone, and no need to worry. So likewise, if I need to close this file, I can just press this cross sign, no need to manually move anything. But the hardware itself do the hard thing, right? And in the case of disks, so I have shown you an example. A typical abstraction would be that the disk contains a collection of named files. Each file can be opened, read, write and close. So normally a disk will contain several files, and it is in this format. Here saved file, it's a little scratch on the disk, and you can't see it with your live eyes. The program that hides the truth about the hardware from the user and present a nice simple view of named files that can be read and written is the operating system. So imagine you should save your files manually on a hard disk each and every time you save a file. So you can't organize it, you can't easily preview them. But here in the operating system, so in the file explorer, here you can view them. Here if I click on this one, it's going to preview it for me. But actually in the hard disk you can't see anything. It's just a file, raw file. It's in ones and zeros and in other formats, but you can't easily read them, right? So let's go forward. Alright, so this is the truth about the operating system and the computer components. Here hardware has ugly interfaces. So think about this thing. So here this is the hard disk, so here you can't understand these things. So it's a ugly interface, and operating system will convert this ugly interface to a beautiful interface. So normally we have the buttons, menus, icons, likewise. So we call them as graphical user interface. So normally operating system has graphical user interfaces and also buttons, menus and icons. So within one click you can access the files in your hard disk. Otherwise you should manually access, it's impossible, because you should learn electronics and other complex things. And operating system as a resource manager. So this is one usage of operating systems. Now we are talking about some uses of operating systems. A modern computer consists of one or more processors, memories, disks, printers and wide range of other devices. So if I go to my file explorer and this PC, I have 3 hard disks. Here one is SSD and other one is other 2 are hard disk, physical hard disk. So I'm not managing these things. The operating system by itself managing the disks. So the job of the operating system is to provide for an orderly and controlled allocation of the above devices among the various programs competing for them. So let's get my example. So let me go to the task manager and show how many softwares are running in my computer. So here you can see currently 3 active apps are running, 5. This Brave browser is running, Microsoft Edge is running, OBS Studio, the recording software is running, Windows Explorer is running, and it is so you can see here 66% of memory is used, and 0% of disk, and 3% network. CPU power 72 is in use. So if I go to the performance, you can see, you can check it by yourself also. So here I have a 12 GB memory, and there are 66% is used in use, right? So I'm not aware about this. So the operating system is managing the 12 GB RAM for myself. So it's RAM managing the RAM for me, but I'm not going to physically manage anything. And think about the CPU. Here it's currently how much percent? 83% is used. So 72, 70 likewise. So here we have two cores, and I'm not aware about that. So the operating system by itself is managing these things, right? So it's very helpful. And let's see, operating system need to keep track of who is using which resources. So imagine you are going to borrow books from a library. So the librarian and the library system will keep track of the books and other materials which you borrow from the library. Otherwise, they will vanish. People will do many things for the books and other resources, right? So here, so the operating system will grant resource request. It will account for usage. It will document this software has used RAM for this much of time. This software has used CPU for this much of time. Likewise, it will keep some records. And then we are going to talk about two special things. The resource sharing, we have two ways, in time and space. So this is something like this. So imagine you are going to ride a bicycle. So you are going to ride a bicycle, and it will the owner of the bicycle will say, you will get 1 hour to ride my bicycle. So that's it. So after 1 hour you should return it back. And imagine you are going to rent a house or a office space. So this is an huge floor of a apartment or something, and the owner of this floor has divided the single floor into 4 parts, A, B, C, D, and you will tell, I need only one part. This part A is enough. So any other can rent the part B. Other person can get the C part and the D, but you are in the same floor, 4 partitions. So that is how you divide space. So when it comes to the RAM, this will happen in another way. So it will happen like this. So I have shown you, I have 12 GB RAM. So imagine you can logically divide the RAM into parts. So I'm going to divide into 4 parts, 4 equal parts. So this is going to be 3 GB. GB means gigabyte. We'll discuss about them later. Another one also 3 GB. So 4 3 GB parts, 3, 6, 9 and 12. So then imagine the OBS software, this one, it's a memory consuming software, so it needs 6 GB of RAM. So what the operating system does, it will allocate these 2 parts to the OBS Studio. So OBS Studio, it's using 6 GB, and for other parts it will allocate 2 GB from here, 2 GB, and here I have 1 GB left and another 3 GB left. So here for altogether 4 GB free space, 4 GB free space, and 8 GB is utilized. 8 GB is utilized. So once I have quit the OBS Studio, if I quit this one, what will happen? All the 12 GB is released. So all the 12 GB memory space is free, right? So that's how you use the time to manage resources, and this is how you use the space to manage resources. So let's proceed further. Operating system as a resource manager. In time multiplexing means sharing resources. different programs take turns to use resources. First one gets to use the resources, then other likewise, right? So it's like a queue. It's like a queue. Time multiplexing is like a queue. So you have A, B, C, D, E processors, and first it will give the priority to E. Once it's done, it will give to the priority to D, C, B, A. Likewise, operating system determines who goes next and for how long. So it will keep track of the time. Right? It will keep track of the time when it comes to time multiplexing. Time. It will give only a limited period of time. Then we have the space multiplexing. In space multiplexing, each program gets part of the resource. Here, for example, so I have taught you this example. Main memory means RAM. RAM is divided up among several running programs, and it is more efficient to hold several programs in memory at once rather than giving it whole to one program. So I have 12 GB RAM, and operating system don't let one program to consume whole RAM, all 12 GB. It will only give several sections, 1 GB, 2 GB, 512 GB, likewise, right? Then, right, so two types of resource sharing methods: the time multiplexing and the space multiplexing. Right, so let's see some other materials also. Let's get some examples for time multiplexing. Okay, so time multiplexing. So let's see whether we have some videos. So let's go here. No example for that. So anyway, you can understand it. It will give the resources for certain time of period. Maybe 1 second, 2 seconds, 1 hour, likewise. And space multiplexing, we'll see whether we can find some graphics for the space multiplexing in computing. Right, here we have. So here the memory is segregated or divided into several parts. Here equal 5 parts, and one part will be given to something for a fixed time, right? Then after the job is done, it's going to reallocate, right? It's going to be free. Okay, so right, no more resources available in the internet, but doesn't matter. I think you got my point. Simple thing. Then we can discuss about the functions of an operating system. So it is going to manage the memory management. It's going to manage processors, devices, files, security, and it will manage the system performance. And there are some jobs. Jobs means updating, antivirus, virus scanning, likewise. Those are jobs. Error detecting, sometimes you will get blue screen errors and stuff, so it will keep account there. Coordinate between other software and users. So for a computer you can log with multiple users, so it will keep track of those users. And here we have the memory management. Main memory provides a fast storage that can be accessed directly by CPU. Main memory means RAM. For a program to be executed, it must be in the main memory. So here can you see, I haven't saved this document. So this is in the memory. So when I draw a line, it is going to be stored in the main memory. It means on the RAM. An operating system does the following activities for memory management. Let's see what it does. Keep track of primary memory. Primary memory means RAM. Who is using RAM? What part of it and is used by whom? What part is not? Free space and occupied space. So then don't need to think about these things. Then we have the processor management. So processor management means, in multiprogramming, it's a concept. the operating system decides which process gets the processor, when and for how long. So some programs need processing power, so then the operating system will decide which process for how long time, likewise, right? And operating system does the following activities for processor management. So it will keep track of processor and its status. The program responsible for this task is known as traffic controller. So it's like a traffic controller, and it will keep track of processes, right? And here allocates and deallocates the CPU processor to a process. So the operating system will allocate and deallocate the CPU to a process. And what's next? So no need to remember all of these things, just remember 4-5 of these things. Device management. An operating system manages device communication via their respective drivers. It does the following activities for device management. So keep track of all devices. The program responsible for this task is known as the I/O controller. I/O means not input and output control. And it will decide which process gets the device, when, for how long, right? And allocates and deallocates the devices most efficient manner. Then right, so these are little things, just go through. And file management, so we have discussed about these things. A file system is normally organized into directories. So directories means folders here. So if I go to this PC and inside the C drive, here I have some directories. Here program files, logs, program data, users, windows, likewise these are directories. Directories means folders. So keep track of information, location, users, status, etc. So if the file is corrupt, it will show file is corrupted, you can't open this. If it is a Word file, it will show the Word icon. If it is a PDF file, it will show the PDF icon. If it is a music file, MP3, it is going to show it as a MP3. If it is a movie file, it is going to show the preview. And decides who gets the resources. Allocates and deallocates the resources, we have discussed about that. Then other important activities. So operating system is accountable for the security of the device. By means of password and similar other techniques, it prevents unauthorized access to the program and data. So it will prevent unauthorized access for the programs and data. So it's accountable for the security. And then control over system performance. So two words, system performance. So it will record the delays between requests for services. It means it will gather the diagnostic information. So when I join your lecture, my computer doesn't work well, so it lagged and I restart the computer. Maybe the operating system keep records of that event, and then it will provide further updates. And here we have the job accounting, keeping track of time and resources used by various jobs and users. So if I go to my file explorer, I can see recent files, quick access here, recent files. So how the operating system is able to list down my recent files? Because it's tracking my activity. And that's how it is listing the recent files. Otherwise, no way to list the recent files. Other important activities continue. Error detecting, and it will so here don't need to remember these things, and it will coordinate between other softwares and users. So here 3 softwares are running, 2 web browsers and OBS Studio, and also the file explorer. So it's coordinating between other softwares. And then we have a special concept. So operating systems, we can divide it into 2 types. So shell means, in computing, a shell is the user interface for accessing operating systems services, right? So no need to think about this thing. So anyway, there are 2 types of operating systems, the CLI and the GUI. So let's search in the browser what is CLI and GUI. CLI versus GUI. Okay, so we can see some graphics here, right? Okay, this is the most perfect term, this one. Okay, so here, so this is a CLI, this is a CLI, and this is GUI. Here this is Windows 8, I guess. So here you can see icons, but here you can see only commands, right? So let me prove it. So if I go to my Windows here, you can see buttons and icons, right? But I can so let me go inside the folder and show you. Right, so I will go to this your folder, IT 160 Wednesday online, right? So I am inside this folder. Let me zoom in. So here you have two folders, day 2 and unit test. Day 2 and unit test is there, right? So I can double click this one and go inside here, and lecture note 1 is there. So I can do the same using a CLI version. CLI version, you can only type commands. CLI stands for command line interface, and GUI stands for graphical user interface. So I'm going to use the CLI. So I'm going to click somewhere here and type CMD, and this command prompt will open. So this we call the command prompt, right? So command prompt. So here you can't see anything. So here I'm inside the IT 160 Wednesday online folder, but you can't see anything. Yeah? IT 160 online. So in the GUI version you can't see. Here you have two files here, but in the CLI version you don't see anything. So let me show you something, right? I will type dir and press enter. So here it's here now I can see two folders, yeah? Day 2 and unit test. So let me keep it side by side, then you can easily see. So here, so this is day 2 and unit test 2, unit test. So here also I have the files here, dir. Directories means I have mentioned folders. So here day 2 and unit test, right? So if I need to go inside this one, how I can do? I can double click. It is lecture note 1, but here I can't double click. I should type something else. So let me type a command. You don't need to remember these things. The command is cd space, then you can type, it's day 2, day-2, and press enter. Nothing has changed. Here the path is changed, but you can't see the files. Here you can see lecture note 1. So let me show it. I should type dir to show the files. Here now I can see it here, lecture note 1 PDF, and here also I have the lecture note 1 PDF. I think you got my point, right? So this is CLI. There, to see something, to modify something, or view something, you should type the command. But in GUI here you don't need to do such. You can just double click and go and use the buttons and menus, right? I think you got my point. Clear or not? GUI versus, alright. Okay, so nice to hear that it's clear for you, right? Okay, so let me close the CLI version, this one. So if you like, you can use to it, you can get used to it. It's very fast and secure, right? So here more details on GUI, graphical user interface. It is a type of user interface that allows user to interact with electronic devices through graphical icons and visual indicators. For example, all versions of Microsoft Windows utilize GUI. So here you have start button, task icon, Windows notification area, time and date, but they are in the CLI, you don't have such thing. So let's go to CLI. Here is a CLI, command line interface, is a text-based interface that it allowed to operate software and operating system while allowing user to respond to visual prompts by typing single commands into the interface. So there you should type commands. So examples for CLI systems: Unix, Linux, and DOS. Then again, types of operating systems. So the CLI and GUI is the basic types, and again we can classify it into several types: mobile operating systems, and here Android, BlackBerry, Symbian, iOS, WebOS, MegoOS, and here we have MS-DOS. MS-DOS is a single user command line based system. Here It's a non-graphical command line interface. So this is an example for MS-DOS. So there you should type command. And we have the Windows OS. It's a graphical user one. It's a commercial product. It eliminates the need of remembering the codes. So you have seen I need to remember the codes. dir to list the things, cd to change the directory. So skip folders likewise. Then here we have a little comparison. Here DOS versus Windows. Here DOS means CLI and Windows. So here feature GUI, graphical user interface. Use the text-based interface. DOS is a type of software operating system, so it uses text-based system. But Windows, it uses graphics, images and text. Input system. So in DOS or CLI, you should type it using the keyboard. But here GUI or on Windows, you don't need to use such. You can use multiple things. You can use the microphone, touchpad, likewise, and multitasking. So CLI unable to run multiple processes at the same time, but Windows, it allows us to work with simultaneous tasks. So at the moment I'm recording the lecture and also join the Google Meet. And what about the storage size? The highest amount of storage size available is 2 GB on the DOS, and nowadays we can use up to 2 terabytes. And price wise, DOS is free and Windows is costly. You should buy a premium license. Right. So let's move forward, and it's about the Linux. Linux is an open source and free. It's free to use system, mostly used on servers and like things. Alright, so that's it, right? So that's about the operating system. So let me quickly do a recap. Here you just need to know about the usages and what is the operating system is, right? So let's get some support from the AI tool. So let me open this Copilot and help us to do a quick summary, right? Document in point format. Right, so it will prepare the summary for us, right? So you can also use the AI tools to inspire yourself, but don't totally rely on those things. So this is the summary. Introduction to operating systems. Definition. So operating system is the interface between the user and the computer hardware, or else it manages hardware and software execution. So examples: Windows, Linux, macOS. And functions of an operating system. Here, memory management, processor management, device management, file management, security, system performance, job accounting, error detecting, software coordination, likewise. Then we have two types of operating systems, user interfaces, the GUI and the CLI. So GUI versus CLI. So what is GUI? So this is GUI. Here you can see buttons, buttons, icons, menus. But the CLI, it is like this. So let me select CLI. The command prompt CMD. CMD is the most common CLI in your computer, right? So in Mac we call it as terminal, right? So here this is my CLI. So I should remember commands to list things. If I press dir, it's going to list all the files here, right? So command line. Then what's next? Then see, you know about the GUI. It has icons, windows, likewise text. And operating system has two ways of managing resources: the time multiplexing and the space multiplexing. In time multiplexing, you will get only certain time. You will get only certain time to do something. In space multiplexing, you will get only certain part of the memory to use. And then we have some types of operating system: mobile operating system, MS-DOS, it's a single user, single tasking, Windows GUI, and Linux, it's open source and it's free to use, right? So actually that is that is this, right? So that is the summary of the slide content, right? And especially please try to remember this thing. So in most exams they are going to ask this one, how the operating system works like a extended machine, right? So here this is the answer. So if someone asks how an operating system works like an extended machine, you can write this thing: the program that hides the truth about the hardware from the user and present a nice simple view of named files that can be written is the operating system. So that is the main idea why we are calling the operating system as an extended machine, because within the computer we have another intelligent computer. So operating system itself is doing great job for us. It's handling multiple things. So one thing is it's simplifying the process of dealing with the computer hardware. Otherwise we should manually go there and configure them, but because we have the operating systems, the process is easy, right? So that's it. That's what we need to talk about in this lecture, right? So do you have any questions? Do you have any questions?